Number 8. In letter A, we have to balance this gaseous reaction. By balancing it, we need to find first its coefficients. So, its coefficients are 4, 5, 4, and 6, which can be found on the stoichiometric coefficient V that was placed specifically on the denominator. So this, and these are its coefficients. So the balance equation will be ammonia with a coefficient of 4 that is added to oxygen with a coefficient of 5 to yield a product of nitric oxide with a coefficient of 4 and hydrogen oxide with a coefficient of 6. So this will be the balance equation of the gaseous reaction. In letter B, we were asked to determine how fast is oxygen decreasing when hydrogen oxide is increasing at a rate of 2.52 times 10 raised to the power of negative 2 mole per liter second. So the formula that should be used is rate equals negative delta reactant over V reactant delta T, and rate equals delta product over V product delta T. And then substitute the rate of the increasing product, which is this 2.52 times 10 raised to the power of negative 2 mole per liter second, and apply the cross multiplication as to which negative 5 is multiplied at the product's numerator and 6 is multiplied at the reactant's numerator. So, to find the rate of the reactant, we need to transfer 6 to the right side, in which it will be divided by negative 5 times 2.52 times 10 raised to the power of negative 2 mole per liter second. So, the decreasing rate of the reactant is negative 2.10 times 10 raised to the power of negative 2 mole liter per second. So, that's how fast oxygen decreasing when hydrogen oxide is increasing at a rate of 2.52 times 10 raised to the power of negative 2 mole per liter second.